Welcome to ClickMyProject.com. Now we are going to discuss about analysis and prediction of students' academic performance based on educational data mining. Abstract: the development of intelligent technology gains the popularity in the educational field. The rapid growth of educational data indicates the traditional processing method may have limitation and distortion. Therefore, reconstructing the research technology of data mining in the educational field has become the increasingly prominent. A data mining method have been applied in many aspects of educational data processing, such as student retention, dropout prediction, academic data analysis, and student behavior analysis. The evaluation and prediction of student academic performance have been most important part of EDM. To evaluate the performance using the machine learning, we have proposed and developed the random forest classifier to predict and analyze the student performance and estimate the performance in terms of accuracy. This is our project flow diagram. Our process is going to start with the data selection and loading. We are going to select a data set based upon the educational data, and then we are going to read the data using the pandas library. And then our second module is a data pre-processing. Here we are going to clean our data, and then data splitting. Data splitting means we are going to split our data into training part and a testing part. Training part is to train our algorithm, testing part is for prediction purpose. And then fourth module is a classification, that is algorithm implementation. Here we are going to implement a random forest, which is our proposed algorithm, and then we are going to see our existing algorithm CNN. And then performance metrics. Here we can check the accuracy level, classification report, and confusion matrix. At last, a prediction. By giving a random input, we are going to predict the performance of the student. Now we are going to see our project output. We have 6 modules in our process, and our first module is a data selection and loading. First we are going to select a data set based upon the educational, and then we are going to load into our process. For reading our data set, we are going to use the pandas library, and then we are going to view the sample input data, and then we are going to check the information of our data by using the describe and info function, where we can check its data type and count minimum value, maximum value, etc. And then our second module is a data pre-processing. Data pre-processing means cleaning our data set. First we are going to check whether any null values is present in our data set by using the isNull keyword. And then we are going to do the label encoding. Label encoding means converting our values into from categorical to numerical. Here we are going to convert the column called a class from category to numeric. Our third module is a data splitting. Here we are going to split our data into training part and a testing part by using the train test split library. Training part is to train our algorithm, testing part is for prediction purpose. And then classification. Classification means algorithm implementation. Here we are going to implement 2 algorithms. One is convolution neural network, which is our existing algorithm, and another one is a random forest, which is our proposed algorithm. First we are going to see about convolution neural network. It is a deep learning algorithm which creates the more number of hidden layers between the input and output. Input means it is a layer which we give the input to our model. The number of neuron in the layer is equal to the total number of features of our data. Hidden layers is formed by using the dense convolution 1D, dropout, flatten, and max pooling 1D. These are the layers which we use to build our algorithm. Layer from the hidden layer is then feed to logistic function like a sigmoid or softmax or relu, which converts our output into each classes. This is our model summary, and then we are going to give 20 approaches, which means we are going to iterate our data 20 times. And then this is the confusion matrix for our CNN algorithm, and our CNN algorithm gives the accuracy of 60 to 65%. And then this is the classification report of our CNN algorithm. We have 3 classes. One is 0, another one is 1, and another one is 2. Precision, recall, F1 score. These are the 3 values we are going to get from our report. And then this is the comparison graph between original accuracy and validation accuracy, and loss and validation loss. After that we are going to see about random forest algorithm. Random forest algorithm is a supervised machine learning technique, contains the number of a decision tree for various subset, and it gives the accuracy based upon its average, and it is used for both classification and regression purpose. This is the confusion matrix which generated by the random forest algorithm. and this is the heat map for that confusion matrix, which is drawn by using the Seaborn. And a random forest gives the accuracy of 80%, which is calculated by our predicted value and our original value. And then classification report for a random forest. Here precision means total number of correct prediction, recall means correct prediction at particular instant, F1 score means average between the precision and the recall. At last a comparison graph. It is a comparison graph between accuracy level of a random forest and the CNN. Our proposed algorithm gives the better accuracy than existing, and then by giving a random input we are going to predict the student performance, whether it is average, low or high. Thank you.